Students, welcome to the second class in series solution of differential equations. We have not done anything about the series solution. We just learned two words, singular point and ordinary point, and after that I had given a certain assignment where you had to find the singular points and the ordinary points of differential equation at a particular point. That is, I had given a differential equation along with it a point, and you were asked to find whether that point is an ordinary or a singular point. So you must have done your assignments. And now coming to the power series solution, we'll start with the power series solution in this manner. Power series solution is like this. First we look at the method, and then after that we'll look at how the solution is found out, and we will remember that the power series solution or the infinite series solution or the series solution is required when differential equations cannot be solved by any of the methods given earlier. So earlier we saw that if I have got a second degree equation, then I get a solution like this, as it is a some function of x plus b some function of x. So we used to get the solutions like this. So here we will see that we will not get functions, but we will get infinite series. We will get two different infinite series if we have got a second degree equation, and we will concentrate with second degree equations only. And after that let us go to the method. So for the method, let us start like this: power series solution about the ordinary point. So we have already learned what is the ordinary point. Ordinary point is the point, if it's analytical at that point, then it's an ordinary point. So this is the ordinary point solution, and we will require ordinary point solution only. Now for this, let the differential equation, that is, be y double dash plus px y single dashed plus qx y is equal to 0. This is what we had given in the previous class. We have taken as the given differential equation. Now we will assume a certain solution. Let the solution be, let the solution of 1 be, I forgot to mention here, let the series solution or the power series solution of 1 be, y is equal to summation n goes from 0 to infinity Cn x minus x naught the whole to the power n. Then after that, let us differentiate. Let this be 2a. Differentiating, let us differentiate with respect to x. So differentiating with respect to x, it means 2a we are differentiating with respect to x. What do we get? This is dy by dx, which is y dash. N goes from 0 to infinity. Cn remain as it is because Cn is a constant. I forgot to tell you here. Here the C's are constants. The C's are constants, and this is what, since I am differentiating with respect to x, and we will remember that x naught is a constant. It may be 1 or 2 or something, or 0, like that. So this is n x minus x naught the whole to the power n minus 1. So this is 2b. Please note down carefully. So now we set out to find, since I have got no space, what I'll do is I'll write y dash, and we will remember that after this step we are going to this step. So y dash is again equal to n goes from 0 to infinity, Cn n, then again from here we get n minus 1, n minus 1, x minus x naught the whole to the power n minus 1. So sorry, n minus 2, because we differentiated again. So this is 2c. So we have here, this one is our 2a, this is 2b, and this is 2c. So what we do is we use these values. We have y dash, which we put here, and then we have y single dash, which we put here, and then we have just y, which we already have here. So using a, b, 2a, 2b, 2a, 2b and 2c in 1. So we substitute it in 1 so that we get something like this. So we get like this. When we substitute it, instead of y dash we will get what? Y dash was equal to summation n into n goes from 0 to infinity, n minus 1 Cn x minus x naught the whole to the power n minus 2. This was our first term of equation 1. Then after that we had plus px into y single dash. What was y single dash? It was n goes from 2b we get this, n goes from 1 to infinity, Cn x minus x naught the whole to the power n minus 1 plus qx into multiplied by y. So what was our y? It was just n goes from 0 to infinity, Cn x minus x naught the whole to the power n is equal to 0. So this is what we get when we using 2a, 2b and 2c in 2. I think I forgot the equation number what we had taken. I think it was 1 in 1. Okay, so we like this. So as a result, what we have, we know that these are constants. When we open all these, we get first term as like this. We put n is equal to 0, then we put n is equal to 1, and we get C0, C1, Cn like this. So we get something like this. We get something of the form like this: A0 plus A1 x minus x0 plus A2 x minus x0 whole square plus dot 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 an x minus x0 the whole to the power n plus dot dot dot. It's going to be infinite because you see all of them are infinite series, so it is equal to 0. Now you must be wondering, what are these a-naughts? What are these a's? We never had an a here. Actually, these are just some constants which are formed with the functions with the constant c1, c2, c3. So where we have to write it here, where a0, a1, a2, etc. are functions of the coefficients C0, C1, C2, etc. That means you may have 2c square plus 3c cube, C1 plus twice C2 plus twice C3 you may get. So we have just summed it up. We have together, since twice C1 plus thrice C2 is also a constant, we have put it like this. So these things will become clearer only when we work out a numerical. So when you put it just as constants, this doesn't come out. It doesn't tell you anything. So we will work out an example. So you see, so we get an equation of this type. So look at this. What is x0? X0 is that point around which or at which your solution is required. They have asked you to solve this equation to find about this, which is an ordinary point. So this particular method is used only if x0 is an ordinary point for our given equation, represented by equation number 1. So this is the ordinary point. So it may be x. Sometimes x0 may also be equal to 0. So most of the time we will have numericals where x0 is equal to 0. In that case, what we do is this becomes a1x plus a2x squared, because this is 0, plus anx cube. So most of the time we will do these kind of equations. So this is the method, and after that what do we do? After that now since this one, let this be equation number 3. Since 3 is an identity, all the coefficients of a0, a1, etc. must be equal to 0. So you see on that side we don't have a x minus x0 on the right hand side. We don't have a this on the left. So what we have? We get a0 is equal to 0, a1 is equal to 0, a2 is equal to 0. But then we know what is a0, what is a1. They are combinations of the c's. So as a result, what we have? We get the answers to the constants. So I'll stop here and we'll do a numerical in the next part of my class.